Good morning dear students, welcome back. I am your physics professor Dr. Nagaraj teaching statistical physics, which is part of module 5 engineering physics, computer science and allied branches syllabus. So this is my second video on this topic. In my previous video I was talking about definition of statistics and statistics in physics and some of the applications of statistics in physics, and then descriptive statistics and inferential statistics. I also started with one particular type of distribution which comes in statistics called Poisson's distribution. I just started with this, but I gave only examples, not actual Poisson's distribution. I recall those examples. Look at these examples. Number one, number of accidents happening in a particular period of time, that is 1 year, in particular city or in a particular highway, or number of people visiting a particular shopping mall or temple or a place in 1 day, okay, or number of atoms disintegrating, number of nuclei, radioactive nuclei decay in a given sample of 1 gram or 1 unit mass, or number of photons hitting the surface, photons hitting a given area, okay, or number of steps that you put while walking a distance of 1 kilometer. 1 kilometer distance, how many steps you put. In all these, you can give many examples for these type of counts. See, in all these things I am counting some event. Accident is an event, visiting a mall is an event, decay is an event, hitting the surface is an event, putting steps is an event, okay, number of deaths caused by some pandemic disease is an event, okay, or number of electrons occupying a given certain energy level is an event, okay. All these counts, all these events, examples what I have given excluding that electron distribution, all these events are random and occurring independently. You take any example excluding that electron. Electron, it is not random, it is governed by certain principles, okay. But in these examples, accident is happening randomly, visiting the mall is happening randomly, disintegration is random and independent, hitting the area is random and independent, steps that you put is also random and independent. In the sense, just by knowing the event, what is happening right now, you cannot predict the next event. What I mean to say, let us say in this particular area NH4, say for example, here now one accident occurred, today one accident occurred at 10 a.m. You cannot say tomorrow a.m. again accident will occur, you cannot say, right? Or okay, decay, one uranium 235, it is a radioactive element, highly unstable element, undergo disintegration. I have 1 gram of uranium atom, uranium substance with me. In 1 gram of uranium substance, there are so many uranium atoms. You can calculate with the help of Avogadro number. So in that 1 gram, there are billions of uranium atoms. One uranium atom undergo disintegration now. You cannot say very next moment another uranium is going to disintegrate. When it will happen? Anytime it can happen. So it is only probabilistic. Or number of people visiting the shopping mall. You cannot say morning 9 to 10, 10 to 11, 11 to 12, every 1 hour so many people only visit. You cannot say. So what I mean to say, events are happening in a random and independent manner, and their counts are probabilistic. So how many decays are happening? Probabilistic. How many accidents are happening? Probabilistic. How many steps I am putting? Probabilistic. But one thing, even though they are happening randomly, even though they are happening independently, over certain period of time, over certain interval of distance, over certain area, it comes out to be average. For example, 1 kilometer distance. 1 kilometer distance, I keep steps. Okay, let us say I put about 20,000 steps. First step maybe 2 feet length, second step maybe 2.5, third step maybe 1.5. Every time I cannot put 2 steps only, but 2 feet step only. But over a period of 1 kilometer length, over an interval of 1 kilometer length, sorry, not period, over an interval of 1 kilometer length, if you count the steps divided by 1 kilometer divided by the steps, definitely it comes out to be average. So it is average. Like that accident, see, this year, today there may be one accident, or tomorrow there may not be any accident. Next month, whole month no accident. People are very cautious. Following month, maybe because of some reason there is accident. Okay, there are many accidents. Like that, you cannot say every month 10 accidents only happen. But over a period of 1 year, so almost it comes out to be average. Like that, number of people visiting the mall may not be constant, but if you take the average, it will be almost same only. So what I mean to say, in events, it is not true for all the events, only some of the events like this. In events where individually counts are happening, events are happening randomly, and individual counts may not be same, but average it is same. Such type of events, such type of distribution is known as a discrete distribution, and Poisson's distribution is applicable for such type of distributions. So now I can say Poisson's distribution deals with discrete distribution, and it gives you probability for, follow carefully, it gives you probability for counts of the events happening, whether now 10 counts are happening or next moment 2 counts are happening. Like that, it will give you probability for counts of events happening over an interval. When I say interval, dear student, don't think that it is always over interval of time antande andkobedi. It may be interval of distance, interval of space, interval of volume also. I told you, no, you 1 kilometer walk ಮಾಡ್ತೀರಾ ಅಂದ್ಕೊಳ್ಳಿ, ನಿಮ್ಮ ಪೇರೆಂಟ್ಸ್ 1 kilometer walk ಮಾಡ್ತಾರೆ, 20,000 steps ಹಾಕ್ತಾರೆ. Okay, one step length may not be equal to the next step. First step, second step may not be same, but average ತಗೊಂಡಾಗ more or less it will be same. Or for example, in a container you have atoms sitting here and there. Okay, ee tara irutte atoms ellana. Now your electron is moving randomly. Inside electrons are moving randomly. When electron is moving randomly, it hits with this. Afterwards it collides and goes like this. Next it goes like this. Next it goes like this. Afterwards it may go like this. Afterwards it may go like this. Notice the distance traveled is not same. After each collision, it is not traveling same distance. But when you take the average of all the distances, it so happens that it is going to be the distance between 2 atoms. It is nothing but interatomic distance. Did you understand? So like that, events are happening independently and randomly, but counts, even though they are individual, when it is averaged out, you get the constant value. Okay, so this type of distribution, when we study, we make use of Poisson's distribution. So I said Poisson's distribution is dealing with discrete distribution, which gives probability for counts of events over an interval of time or distance or space or volume. And when it gives the probability, that count must be a number. Count must be a number. Number must be a positive number. You cannot have a negative number. Like a number of accidents happening, you cannot say 0.5 accident happened. It must be a whole number. 2 accidents occurred, 3 accidents occurred, 4 accidents occurred. But average can be fraction, 1.5 per day. See, for 2 days 3 accidents occurred, so therefore for one day it is 1.5 accident only, like that. But here this 3 is there, no, this is a whole number. So your Poisson's distribution is going to give you happenings, counts in a regular intervals of time, in a given interval of time, in a given interval of distance, even given interval of space. Over 1 kilometer it is average. Over 100 meter distance, over 10 meter distance, how much? Like that. For example, hen example. Let us take hen example. I have 20 hens in a room, and you all know each hen can lay 1 egg egg per day. So 24 hours, 20 eggs are collected. Did you understand? 24 hours, 20 eggs are collected. But now my question is, how many eggs are there in 1 hour duration? Let us say morning 5 o'clock I start the count. Morning 5 till morning 5, next day 5, 24 hour duration. So morning 5 I leave all hens into the room. Okay. Now after 1 hour means 6 o'clock I go and check. 7 o'clock I go and check. Maybe 10 o'clock I go and check. Okay. So after 1 hour, whether one hen laid the egg or 2 hens laid the egg. If 2 hens laid the egg, there must be 2 eggs after 1 hour. After 3 hours, there may be 2 only, or there may not be even a single also. That means none of the hens have laid the eggs yet. But by the end of 5 o'clock next day, definitely there will be 20 eggs. Got it? So this what you call as in a regular interval of time or a given interval of time count. In a given interval of time, how much? Like for example, I have 1 gram of uranium. Now I start my watch. In 2 seconds, how many uranium atoms undergo decay? That is what is called probability count in a given interval of time, and that probability count is represented by K. Please follow carefully. K is a whole number, non-negative, non-zero number. Next, over given period of time, over given interval of distance, over given space, it can be average, and that average is lambda. Right. So coming to this example, you take 3 accidents as K, 1.5 is lambda. Lambda can be fraction, can be whole number also. It is average happenings. Like 1 kilometer distance, 20,000 steps I put, then per step, what is the distance? 1 kilometer means 1,000 meter. 1,000 meter divided by 20,000 steps, cancel. 1 by 20 of a meter. 1 by 20 of a meter is nothing but, okay, so it is 0.5 into 10 power minus 1, that is 0.05 meter. Got it? 0.05 meter means 5 centimeters, something like that. That way you can calculate. So this is about whole number, means the events happening in a particular interval of time, and counts occurred over certain interval, or average count. Average count is lambda. Count in a particular interval of time or space is K, and the probability of appearing K is P. Now we have 3 parameters with us, and these 3 parameters are beautifully connected by this equation, that is P of x is equal to K. X is variable, which is K, is equal to lambda to the power of K e to the power of minus lambda divided by K factorial. This is my Poisson's distribution. I repeat, lambda is the average count over a given interval of time or space or volume. K is the count in a particular interval of time. K factorial you know, P is the probability of that K happening, right? And then X can be any value of K including 0. For example, hen example, best example, hens, 20 hens in a room. Morning 5 o'clock, how many eggs are available? Or probability of 0 egg available from 5 to 6, then K equal to 0. Or probability of getting 10 eggs from 5 to 6, then K is equal to 10. Probability of getting 2 eggs from 5 to 6, then K is equal to 2. I cannot say probability of getting 1.5 egg, because half egg no hen will lay. So that is the meaning of K. K can be be 0, can be any number other than negative value. I said k cannot be 0, but sometimes it can be 0 also. That means no happening at all. No count started yet annotara. Actually, dear students, I tell you, this Poisson's distribution was first adopted by one of the statistician way back in 1870s in Persian army. In Persian army, there were many troops which we call them as corps ಅಥವಾ groups. ಆಯ್ತಾ, ಈ ಆರ್ಮಿನಲ್ಲಿ ಗ್ರೂಪ್ಸ್ ಮಾಡಿರ್ತಾರೆ, ಡಿಫರೆಂಟ್ ಗ್ರೂಪ್ಸ್. ಓಕೆ, and in those days soldiers, they were dying because of many reasons, maybe pandemic, maybe some wounds due to war, or maybe some weather change, or maybe because of unexpected reasons like horse kick. Okay, horse kick is a dangerous thing, you know. Sometimes, no, they, without their knowledge, the horse will kick and they will collapse. Within no time they die. This is one of the dangerous and very serious cause. Okay, and that statistician, he wanted to study how many soldiers have died just because of horse kick, not because of pandemic or not because of any health issues or wars or wounds or age factor or any other things ಅಲ್ಲ, ಡ್ಯೂ ಟು ವೆದರ್ ಚೇಂಜಸ್. ಅದಕ್ಕೆಲ್ಲ ಅವ್ನು ನೋಡಿದ್ದು ಹಾರ್ಸ್ ಕಿಕ್ ಇಂದ ಎಷ್ಟು ಜನ ಸತ್ರು. He just wanted to check how many are died because of horse kick. So for that he selected 10 groups, 10 corps, right? From 10 corps, 10 years he studied, last to 1860 to 1870, 10-year duration he studied, and he counted, you know, the data was available. That is what you have to record, everything you have to record. From the data you can make the observation and you can predict. This is a statistics. I tell you, dear students, this is statistics. ನೀವು ಡೇಟಾ ಮಾಡಬೇಕು, ಡೇಟಾನ ರೆಕಾರ್ಡ್ ಮಾಡ್ತಾ ಹೋಗಬೇಕು. ಫ್ರಮ್ ದ ಡೇಟಾ ಯು ವಿಲ್ ಗೆಟ್ ಸಮ್ ಇನ್ಫರೆನ್ಸ್, ಸಮ್ ಅಬ್ಸರ್ವೇಷನ್, ಸಮ್ ಕನ್ಕ್ಲೂಷನ್. ಸೊ he studied the previous 10 years data and he came to know that there were 20 deaths over a certain period of time. 20 deaths over certain period of time. Okay, 10 year or 20 some period of time, 20 deaths, right? And then he verified every 1860 to 61 how many deaths, 61 to 62 how many deaths, 62 to 63 how many deaths, like that he counted. In particular year he could see 4 kicks, 4 deaths due to horse kick. That was very fatal year, like this. In 61 to 62 there may not be even a single death. 60-61 maybe 1 soldier died. 62 to 63 maybe 3 soldiers died. Like that, one bad year, one unfortunate year, 4 soldiers died. All these things are K values. Got it? And he averaged it out. 20 deaths not in 10 years. I forgot how many years duration he studied, and he got that average value as 0.61. Now dear students, come on, tell me among them which is K, which is lambda. Can you tell me? Sir, this is K, this is K, these are all K, and this is lambda. So lambda and K, you got it? So substitute and then you can find the probability. This is Poisson's distribution, and Poisson's distribution you can plot by taking probability along x-axis and then what? Lambdas and K values along y-axis. Sorry, probability along y-axis, K along x-axis for different lambda values. Okay, so initially that graph will be like this. That means left distribution is very less, right distribution will be more. But when this is for one particular lambda value, when lambda increases, when lambda is very small, it is like that. When lambda increases, means the probability increases. This we will see in the numerical section. So the graph will assume some shape like this. For larger value of lambda, graph will take this shape. This is called bell curve. curve. This I will discuss later on. Bell curve is nothing but uniform distribution, both left side as well as right side. Some distributions are left biased. Some distributions, I will write it here, some distributions will be more towards the left, more towards the left. There is no distribution to the right. Some distributions are left right biased, more distributions to the right, no left. Some distributions are random. Some distributions are random. Sorry, I am also writing random. Please don't get confused because I don't find sufficient space to draw the graphs. So this is left biased, this is right biased, this is unbiased but random. But here left and right distributions are equal. This is called normal distribution. I will talk about this normal distribution later on. Still there are many more things to discuss about the Poisson's distribution. So Poisson's distribution tells you about the probability for counts to occur in a specific interval of time or space or volume given by this formula. K is the number, lambda is average value, and P is a probability parameter. Well, we will make use of this equation to discuss what is called proton decay modeling. Proton decay modeling, that is very important problem. Okay, well, I will start with proton decay now.